To the summary of the Chapter 3 video. I hope the sub has passed out the notes. This will help prepare you for your quiz on Friday and your test on Tuesday. Let's begin. Derivatives is a rate of change that can tell us many things, but first and foremost, it tells us the instantaneous slope of a function. That is what the definition of the derivative is. This will tell us whether a function's values are increasing when the slope is positive or decreasing when the slope is negative. We notice that when slopes change signs, we achieve relative extrema of the original function values. Remember, relative extrema will be defined when we review section 3.1. We'll talk about that there. If we analyze the second derivative, or the slope of the slope, we're able to tell a lot of cool things too. Most notably, we'll be able to change where a function changes its concavity. This is useful in sketching functions and finding relative extrema with the second derivative test. Finally, if a function satisfies certain conditions, we can guarantee the existence of certain properties of that function. By Rolle's theorem, we can guarantee there's a critical value of the function in a closed interval. The function has a derivative of 0. We have to check certain conditions first. The first condition is it has to be continuous on a closed interval. It's be differentiable, which means you can take the derivative on the open interval, a to b. And finally, f of a has to equal f of b. And if all those are true, then there must be a critical value where the function is a derivative of 0. By the mean value theorem, we can guarantee there's a value in the closed interval in which the derivative is equal to the average slope. Same conditions as first two in Rolle's theorem. Continuous on a closed interval. Differentiable on the open interval. Okay. I'm not going to go through these in great detail. You can all read. These pages in your note packets are meant to be a summary of things you should know from each section. This is more for the test review on Tuesday than your quiz on Friday. You will be quizzed on 3.3 and 3.4 and 3.6 on Friday. So these things are just meant to help you practice. I'm not going to go through these in the video. I'll place the completed notes on Schoology at some later time, but these are just to help you prepare for the test. Some examples for you to do. Here's a full statement of Rolle's theorem. It means the mean value theorem in case you're curious. This is the thing I did not write down on that page. The actual conclusion of these theorems or what they actually mean. So if I look here on your note sheet, that's actually what the mean value theorem states. It states that there is some c value in that interval where f prime of c is equal to the average slope, or f of b minus f of a over b minus a. Here's another problem that I sort of talked about in class. The one thing I'll note about this problem is that there are two stationary police cars equipped with radar. This semi-truck's travel is continuous and differentiable. It's continuous, first of all, because you can't just stop moving and jump to a different point. So it's a continuous path because you're heading down the road, and there's no way that a truck can all of a sudden jump from here to there without hitting every point in between. And it's differentiable because there's no quick jerks or asymptotes or holes or any cusps here. There's no way you can just stop and all of a sudden start going the other direction. You have to decelerate and accelerate there. So it does satisfy the first two conditions of the mean value theorem, and you're going to use the mean value theorem to answer this problem. 3.3, this is the stuff that you need to know for Friday. How to check whether a function is decreasing, where it has a negative slope, constant, where it has a zero slope, or increasing, where it has a positive slope. Again, I'm not going to read through all these. You can read these. The guidelines here, this is going to be the stuff that's going to be helpful for you to get steps on how to do this stuff. This is also going to be on your test, but this is something we already knew how to do. It's how to find those maxima and minima values. So notice that it has to change slope from negative to positive or positive to negative. If there's no change in sign, it's not a relative maximum nor a relative minimum. But you'll find out again in 3.4 at that point, if it doesn't change signs, sometimes can be an inflection point or point of inflection. Find the relative extreme of the function f of x equals 1/2 x minus sine of x in interval 0 to 2 pi. Again, I'll tell you how to start this, but I don't have time to go through the whole problem. What you want to do is you want to find f prime of x. And what you want to do is you want to set that equal to 0 or undefined. So there's no time in which cosine of x is undefined or 1/2 is undefined. So we're just going to set this derivative equal to 0 and solve. So what's going to happen here is you're going to get cosine of x. Sorry, negative 1/2 is equal to negative cosine of x. You're going to divide by negative 1, and you want to know when is cosine of x equal to 1/2. Well, there's a couple times within this interval 0 to 2 pi. So 0 to 2 pi, you're imagining one complete cycle of the cosine function. You want to know when it's equal to 1/2. Well, we need to know the unit circle. There's 2 pi here. When is cosine 1/2? And you should remember that positive 60 degrees or pi over 3 would be the first spot where you're going to have a adjacent side of 1 and a hypotenuse of 2. Oops. And I suppose that's more for special right triangles in the unit circle, but you should know that the cosine of x is 1/2 at pi over 3. And of course, all students will take calculus. That means, again, there's a reference angle down here in the fourth quadrant where I'll have the same thing. It would be 2 pi minus pi over 3, which would be 5 pi over 3. Those are the 2 times, so x would have to be pi over 3, 5 pi over 3. What you're going to do is you're going to make this is the first derivative test. You're going to find the spots, so between 0 and 2 pi, you're going to make intervals, and you're going to test points. So pi over 3 would be somewhere in here, 5 pi over 3 would be somewhere in there. So you have to check 3 different intervals, here, here, and here, and just determine if there's sign changes. Spoiler alert, there's probably going to be because we have cosine. Go to the next slide. 3.4, this is also going to be in our quiz on Friday. Concavity is defined here. Point of inflection is where the second derivative is equal to 0. That's the big thing that you need to know. Where the second derivative is equal to 0 and or is not differentiable. Okay. The second derivative test, this is the thing that helps you find extrema. The second derivative test is not for concavity. Second derivative test is to find extrema. Find maxes and mins. Test for concavity is up here. So note that sign changes in the second derivative will tell us concavity. The second derivative test just tells us that if we find critical values of the first derivative and plug them into the second derivative, then we'll know whether it's a maximum or minimum depending on whether it's concave up like a cup where it'd be a minimum or down like a frown where it'd be a maximum, which is sort of weird because that means the second derivative is negative or positive, which seems opposite. When you see min, you think negative, but in a minimum, the second derivative has to be positive because that's to be concave up like a cup. So to find the relative extrema using the second derivative test, what you would do is, of course, find the first derivative. And by the name of the game, you have to find the second derivative as well. So we'll do that quickly here. I don't have a ton of time because this video can only be 15 minutes long. So we have negative 60 x cubed plus 30x squared, or just x. Hopefully I'm not making too many mistakes here. So what you want to do first with the second derivative test is find the critical values of this. So we're going to set that equal to 0. 15x to the 4th plus 15x squared. We're going to factor out what we can negative 15 and an x squared. We'll be left with x squared minus 1, which means I'm going to factor that into negative 15 x squared times x plus 1 x minus 1. So the critical values where this thing is 0 or undefined would be x equals 0, x equals negative 1, and x equals positive 1. And what we're going to do, instead of making the normal candidates test where I'm going to use these intervals of increasing or decreasing, I'm actually instead just going to plug these values into the second derivative for x. And this is nice because this way you don't have to necessarily make intervals of increasing or decreasing, you just plug it in. And so you'll see whether it's a maximum or minimum. Let's just do one example. F prime of 0 would of course be 0. Now is that a max or a min? According to my second derivative test, no, that doesn't tell us anything because the second derivative test tells us only if when the second derivative is positive or negative. We know here the second derivative is 0, so that's a point of inflection. So that's neither a maximum nor a minimum. How about f prime of 1? Well, or f double prime of 1, excuse me, would be negative 60 plus 30. So that'd be a negative 30. So that means that x equals 1 is the location of a, you guessed it, max. Okay, if I do this negative 1, it's going to be positive 60 plus 30, because negative 1 cubed is negative 1 times negative 60 is positive 60. That means I have positive 90. So that means x equals negative 1. There's a location of a min. Think about why that is. Second derivative is positive, up like a cup. Second derivative is negative, down like a frown. That's the second derivative test. This is kind of the behemoth one, 3.6. This is where we have to sketch functions. Now, there's a lot of things to check here that would help us sketch the graph. And I am not going to read through this list. You guys can all read this. But these are the steps here. Okay, you want to go through and check each one of these conditions, find what they are, and use them to help sketch. Once you plot the points and you know the behavior, you should be able to, just sketch a rough picture of what's happening. Now, the domain of the function and everything else, if you're not familiar with this, you check 25. I don't know why I crossed it out. 26 would be another one for symmetry and some other things, odd and even functions. That stuff is all in there. Remember that symmetry with respect to the y-axis exists if f of negative x equals f of x. And so that's an even function. And odd functions are here. That means f of negative x equals negative f of x. It's symmetry to the origin. So page 5 is a good place to check. If you don't remember how to find discontinuities, check section 1.4. If you don't remember how to find asymptotes, do 1.5. Vertical asymptotes, 1.6. If you're having trouble finding horizontal or oblique asymptotes. Okay, section 3.5 is also helpful for finding end behavior as well. Again, I don't have time to go through these examples for curve sketching, but you'll notice that if you have a QR scanner, I'm pretty sure these still work. I'll verify that after I make this video, but you should be able to scan that and see a video of this being made. If that does not work, I will have access to a computer this weekend, and I'll be able to complete these examples as well in a separate video for you to watch later. But I would encourage you first to check with your QR code scanner. Again, if you don't have a QR code scanner, I know that's very 2012, but I want you to download one off the App Store or use your camera app. Sometimes we'll have a QR code scanner built in. You'll see that there is a video of this stuff being done. That's meant to help you. Please don't hesitate to contact me. Today you will be just working to finish the review here. You'll be basically preparing for that quiz you have tomorrow and the test you have on Tuesday. I keep messing that up. Let me know if you have questions. Have a great weekend, and I will see you on Monday.